The geometric power series, you remember, we went this direction. Sum as n goes from 0 to infinity of a times r to the n is a divided by 1 minus r for all r less than 1. We've done them this way, but what if we reverse it? What if I tell you that if I have a function a divided by 1 minus r, it can be represented as a geometric power series, again, as long as the absolute value of r is less than 1. Now, what if I let r equal x? So now I'm going to have a function of x. Again, we need the caveat that the absolute value of x is less than 1. Let's look at one in particular. Suppose I let a equal 1. So I can take 1 over 1 minus x and represent it as a sum, as a series. And of course, it converges only for x less than 1. The radius of convergence is 1. The interval of convergence is -1 to 1. It's quite straightforward. If I plug in the endpoints, I'm going to get a divergent series. All right, now let's try to find the geometric power series for 4 over x plus 2 centered at 0. Now remember, I'm trying to get 4 divided by x plus 2 to look like a divided by 1 minus r. So this is what I'm trying to do. So let me rewrite this as 4 divided by 2 plus x. So the first thing I did was I got the number first in the denominator. Now, the next thing I want to do is I want to make the number equal to 1. So in order to do that, I'm going to divide both numerator and denominator by 1/2, or multiply by 1/2. How about that? So this becomes 2 divided by 1 plus x over 2. So that was the first step. Maybe it's the second, depending on how you count. Now I need this to be minus r. So this is going to be 2 divided by 1 minus, but I've got a plus there, so I need a negative. All right, now it's quite straightforward. A in this case is equal to 2, and r is negative x over 2. So I can write this: 4 divided by x plus 2 is the sum as n goes from 0 to infinity of a r to the n, which is a sum as n goes from 0 to infinity. A is 2, x minus 2 minus x over 2 to the n. Now, where does this converge? Well, it converges when the absolute value of minus x over 2 is less than 1, or when the absolute value of x is less than 2. So I have an interval of convergence of -2 to +2. Now, what do you do when you want a power series that's centered at, say, 1? Well, now remember, we want f of x to be of the form a divided by 1 minus r. So I've got 1 over x down here. So I need to do some stuff down here. So let me just look at this. I'm just going to write this 1 minus r, and I'm going to take x. I'm going to put the x right here. Now I need a 1 in there, so I'm going to add 1, and if I add 1, I have to subtract 1, right? Because I have to keep it balanced. Now I need this to be minus r, so I need to subtract out r, which means I need to multiply by -1 everything in here. Now let me run through my algebra here and see if I have this right. 1 plus x minus 1 is just x. Okay, so I didn't make a mistake with my negative sign, so this is just a check, and I always check. So if I come back up here, I've got the 1, I've got the minus, and this tells me r is minus x plus 1. All right, so I can now write 1 over x is equal to the sum, as n goes from 0 to infinity, of a r to the n. So this is a sum, as n goes from 0 to infinity. I didn't identify it, but it's just 1. That's pretty straightforward. Okay. Times r to the n. And r is, let's see. I want to put it in the form, I want it centered at 1, so we tend to write it this way. So I'm going to write r like that. So this is minus 1 times x minus 1, whole thing to the n. Another way I can write this is the sum, as n goes from 0 to infinity, of minus 1 to the n times x minus 1 to the n. Where does this converge? Well, of course, it's going to converge when the absolute value of x minus 1 is less than 1. So, what is my interval of convergence? Well, when negative 1 is less than x minus 1 is less than 1, so 0 is less than x is less than 2. So my interval of convergence is from 0 to 2. And of course, my radius of convergence is 1.